I wish you a wonderful day and welcome to the OXL YouTube channel. In this video we will talk about the TProxy functionality in NFTables. What is TProxy? What can we use TProxy for? TProxy stands for transparent proxy, and we can use it to process, filter, analyze some network traffic in a user space process. This can be very useful to extend the filtering functionality of firewalls like NFTables, IP tables. In practice, this is often used to filter network traffic. A practical example for this would be that we are a network firewall and HTTP and S traffic that is passing through this firewall should be filtered on application layer. Thus, we need to implement some proxy service and pass the traffic through it. This is exactly the example we will configure and talk about. We have some network firewall set up and have client servers and devices in our subnets. And if those devices want to connect to some internet service, we want to pass it through our proxy service, in this case Squid, and check if we want to allow or deny that access. The traffic from our client servers and devices hits us at pre-routing, where we will add a routing mark, and configure the TProxy. Then it hits our internal routing, gets sent to our loopback interface. Thus, it comes to the input chain where the actual TProxy service is listening. And if the connection is allowed by the proxy service, the proxy will connect through the output chain to the internet service and respond to the clients. And in the second example, we will take it a little further and also filter the traffic that is originating from our firewall, so the outbound traffic from our firewall. And thus we need to categorize the traffic that's outbound on our firewall into traffic that's originating from the proxy and was already filtered, and the traffic that still needs to be sent to the proxy and thus filtered. This is of course a little bit more complicated. If you don't already have experience in using and configuring NFTables, I would recommend you to watch our NFTables intro playlist and get to know it. Because the TProxy functionality is a little bit more advanced, and starting off with it might be a little bit of a steep learning curve. Before starting to configure the TProxy functionality, we will have to prepare the routing for it. We will first add a routing table. In this case, we'll call it proxy underline loopback and give it the ID 200. We will also use that 200 as firewall mark later on to conditionally route traffic to our loopback interface. Let's just add that config. And then we will have to define some IP rules, where we define that the packets that are marked with the mark 200 get routed to this loopback table. I have already configured them, so I will not execute those, but also for IPv6 we can add that rule if you use IPv6, and then we will add our default route in this table that targets our loopback interface. So all of the traffic that is routed in the table is targeting the table will be routed to our loopback interface. Also, this route has to be added for IPv6 too if we use IPv6. We can check if those routes and rules are set using the IP route show table all. Many routes here, so we will grab on proxy as we have named our table proxy, and we can see the default route for IPv4 traffic is in here. Of course, you can also use the IP-6 to show the IPv6 route. And using the IP rule list, we can show our rules. In this case, we see that the packets with FMARC 200 in hexadecimal are using the proxy loopback table. We will also have to configure some sysdetail settings. First, let's start by disabling the RP filter on our internal interfaces and also loopback. These are our interfaces. In my case, I have to disable it for EMB2 as 0. The RP filter actually silently drops traffic if the traffic should logically not be routed to that interface. In our case, we will route public traffic on our loopback interface, and thus it might be dropped by this filter. We will add it for our EMP interface, our internal interface, and also for our loopback interface. Yes, after that we will also have to enable traffic forwarding. In my case, as I'm already using this firewall as network firewall, I already have enabled it. Let's copy it out and execute it one more time. To make those settings persistent, we will also add them to the etc sysdetail-conf. Let's just copy it. And then we'll paste it into the config. Here we already can see that RP filter mentioned here. And let's put it in there, also for loopback. And of course the IP forwarding is already enabled for my system. And below you can also see the forwarding for IPv6 traffic if you use IPv6 traffic. Okay, so far so good. Now we'll also have to make the IP route settings we've configured before persistent. I have already added a script to create those rules and routes. We will need to execute that script at system boot time and also whenever the networking gets restarted, because a networking restart also flushes routes. This script will check if the rules and routes already exist, and if not so, it will add them. It is important to only add the rules if they don't exist, because they can be duplicated and we would not want to do that. Yeah, exactly. I personally like to use systemd overrides to add such hooks. You can of course use other means of doing that. Also the script and config we will see later on is mentioned in the documentation that is linked in the description. So if you need to copy paste it or look it up later on, it's there. In my case, I'll now add a systemd override for the NFTables service to execute the script at NFTables startup. For that, we will create a directory at etc systemd system and NFTables service t. In my case, it already exists. And after that, we can create a override conf inside the directory. Already exists for me. And we can see some lines. the script is the exec start post in this case. So after the NFTables configuration gets loaded at system boot time, we will execute that script and thus add those rules and routes. I will also create such a directory for the networking service. So the script gets executed at networking restart time. I already have created it and it looks like this. As we've created the script to be able to be executed multiple times, it is stateful and thus should not make any issues if we execute it through multiple services. Now we can activate those changes using a systemctl daemon reload. And yeah, of course, we should test if that works by rebooting the system. Now let's take a look at the NFTables configuration. I have split up the configuration file since the last NFTables video, as the configuration has grown pretty big. I have split up the configuration in filters and NUT, so the actual firewall rules are placed in .filter and the NUT rules are placed in the .NUT file. Let's check them out quickly to get an overview. We have the filter file where the input, forward and output hooks are placed, and in the NUT file, of course, there are the NUT chains. Yes, we will work in the .conf in the main file for now. As we can see, those two other files are included here inside of our default table, filter table. We will now add two variables to our configuration. First, the firewall mark that we have used in our routes and will also need to use in our firewall rule set, of course. And then we have a port that the proxy service is listening on. For now, for testing purposes, we have a very dumb script running behind that board. Let's take a look at netstat. We have a script running on other boards, but on the port 3000 that we're using for now, it's just a Python script, and this is pretty much it. We just have a single Python file and it will not respond to any requests. It will only log the ones that it receives. It makes sense to use such a simple script for testing purposes, so we can isolate errors in our NFTables configuration. Whenever the requests start to hit that test service, we're good to go. Our NFTables configuration should be fine. So let's start to configure TProxy for NFTables. I'll just add the rerouting chain here and another user-defined chain without hook. Now, what do we do here? We have our pre-routing mangle chain here that has the hook pre-routing and the priority of mangle. This is the only chain that can have the TProxy target defined, the TProxy action, as we see below. We are filtering the traffic that we want to send to the TProxy here. So only TCP destination port 80 with a source address with internal networks, with private IPs and destination address of public networks, public IPs, is sent to the transparent proxy. Yeah, exactly. In this case, we jump to the other chain, to the user-defined chain, and here we set the mark on the traffic. So the traffic gets routed to loopback and actually comes to the input chain and therefore hits the actual proxy service. And we also have to define that the traffic should be sent to the local port where the proxy is listening. After that, we will have to allow the input traffic, so traffic towards our proxy. We will add another user-defined chain here without a hook. Input transparent proxy in this case, we'll call it, and we accept traffic that is to the destination port 80 from private IPs to not private IPs to public IPs, and we will add another rule here. We will exclude traffic that is sent to our firewall directly, because this rule would also match if our firewall has some service running on its public IP on port 80. We can see the variable host self here with all of the IPs that the firewall has configured, and thus we exclude those destination IPs from that accept rule, as we don't want to allow all clients to access our public web interface or something like that that might be running on the firewall. Exactly. So let's test that configuration for now. Save it and test it. Let's check if we have some configuration error in there. And yes, seems we need to define a layer 4 protocol whenever we create a rule that targets a TProxy or that executes a TProxy action, so to say. Let's just match traffic using the meta L4 proto, TCP in this case. Yes, looks good. Before we now activate our configuration changes, let's see how the client currently behaves if we perform a HTTP request and we see it gets a timeout because our firewall currently blocks all requests towards the internet that are not explicitly allowed. Now, we will also have to add a reference, a jump to our input chain, our input filter chain to enable that proxy input rule. Yes. Now we can reload our firewall config, and if we perform another HTTP request, we see we get an error, but we get a response error. And if we check out our TProxy, we see it has got a request. So the TProxy for forwarding traffic works. We can now replace that TProxy, the testing proxy, with an actual proxy that can handle HTTP and HTTPS connections. I've already set up a Squid proxy, as already covered in the last Squid tutorial video. We can just change the proxy port to the one from Squid, reload our NFTables config. As we can see, Squid is listening on the port. Let's reload the NFTables config and test out if we can actually perform HTTP requests. And woo, we get a successful status code. So the request works, and we also see the request in our Squid proxy logs. Looks good. Nice, nice. Now we also want to handle HTTPS traffic, of course. For that to work, we will have to define some variables. As we have only referenced the TCP destination port 80 for now, we'll create some variables for what ports we want to send to the proxy. Let's call the variable proxy ports. this case, we'll send the ports 80 and 443 to the proxy, and we'll also just define a proxy protos to define the layer 4 protocols that we want to send to our proxy. In this case, only TCP. Now do a search and replace for TCP to port 80 and replace it with our variables. We'll do a meta L4 proto match on proxy protos, and then also match the DHT port on proxy ports. Yes. Replace, and that's it. So we can control what ports and protocols are sent to our proxy using those two variables. Now, as Squid needs a specific listener for handling DLS, HTTPS traffic, we will have to define another variable for that and reference it in our TProxy action. So if our destination port is port 80, unencrypted HTTP, we will send it to the HTTP proxy port, and if it's encrypted, we will send it to the HTTPS port. Of course, if you use another proxy, it might differ in your setup. Yeah, so, okay, looks good. Configuration is valid. Let's reload it and test it. Let's just test if the HTTP still works. Looks good. And what happens if we target the HTTPS? We get through the proxy. The server, web application firewall, denies our request, but we get to the actual internet server. Let's see that in the live view. We can see those two requests in our Squid logs. Okay, nice. That's how we do it. Now, how could we also proxy traffic that is originating from our firewall system? Let's just look at the topology again. Here we see that the traffic that is originating from our firewall system is first hitting the output hooks. We will add a routing mark at the output mangle chain. After that, it passes through the output destination NAT and hits the output filter chain. In the output filter chain, we will have to allow traffic to our proxy, so traffic that is marked, we will have to allow. After that, it gets to the routing stage, routed to loopback. After the loopback routing, we hit the pre-routing chains. We will have to remove the mark from those packages, because if we don't remove them, they will be stuck in a routing loop. And afterwards, after the routing, it will hit the input filter chain where the actual TProxy service is located. If the service and the input filters accept the traffic, we will hit the output filter again, where we will have to check if the traffic is originating from the proxy itself. Then we will allow it to access the internet. If not so, we will drop it. Okay, let's get started. Let us now hop back into our configuration to configure the output mangle chain at first. Let's put it on top. Yeah, we have our output mangle chain here with a hook of output, priority of mangle, and the specific type route that is specifically useful for such cases where we want to mark traffic before routing. Now we will send traffic that matches our proxy protocols, our proxy ports, and has a source IP that is assigned to our firewall. So we have a variable of host self here, and of course targets public IPs to our transparent proxy loop chain. In there, we will also check that the target is not originating from our proxy service, because else we would have a traffic loop again. If not so, we will mark it to be routed to loopback. Exactly. We will also have to add another rule to the pre-routing mangle chain, as we are filtering on source IP net private here, and our firewall might have a public IP that should be listed in host self. In that case, we'll add another rule that matches those IPs of the firewall itself. And the traffic then will also hit the pre-routing chain and therefore be jumped to the transparent proxy user-defined chain. In this chain, we will also have to rework our mark setting process, because here we set the mark on all traffic, and this would also bring us to a traffic loop. Now let's remove that rule and replace it with another one, or two in that case. Yeah, we have the first one that checks if the traffic is already marked, so if it comes from our output, and in that case we will set a second mark, just some dummy mark, whatever, and if that second mark is set, we will not set the actual first mark again, so we break that routing loop, so to say. We'll add a proxy mark out here that is just some other mark that we will not match at the routing stage. And yeah, at the TProxy action, we will not have to make any changes. Okay. After that, we will have to add another rule to our input, because we also match on private nets here. And as mentioned before, our firewall might have public IPs. In this case, we will use the host self again. The rest of the rule is the same. And to finish it off, we will have to add some rules for the output chain, output filter chain, to allow traffic to our proxy. So the first rule is to allow HTTP and HTTPS that is targeting our proxy. So we see it back here. We match that the traffic is not originating from our proxy, but has the mark set, so it will be looped to our proxy. And the second rule will actually allow the proxy service to connect to the internet. It also matches the proxy protocols and proxy ports, only allows connections to public services, public IPs, and it has to originate from the proxy service user. Okay, now reference the output transparent proxy chain. I already have edited here and set the output default policy to drop, so we actually see if the traffic is working over the proxy or not. Okay, now let's check if our configuration is valid. Seems like I have an error here or two. Let's just fix it. I have forgot to define the proxy user variable. Let's just do it. Define proxy underline user. In the case of Squid proxy, the proxy service user is proxy. Of course, you should always use a service user to run such a proxy, at least for security reasons, and of course, if you're using such a firewall setup, also for filtering reasons. Yeah. Okay, let's now check if the configuration is valid and reload it. And let's test it. We'll send the traffic to our test proxy again to make sure it actually hits the service behind the TProxy. We can see, yeah, output traffic from our firewall system hits our test proxy, and if we connect from our client system, it also hits the test proxy. Nice! That's what we want to see. Now, let's put in our squid proxy again, reload the config, retest the connection, and we're in the internet. Yes! Now, for testing purposes, just remove the port 80 from the proxy, and nope, without the proxy, HTTP does not work. Of course, we also see those requests in our squid logs, in our proxy logs. Yes, that's the IP of our firewall. If we now just create another HTTPS request, we will also see those requests in the logs. Exactly. Now, that's it for this video. I hope it was interesting, and if you have some complex setups, need some help, please feel free to contact us. And for now, have a nice day and servus.